let's look at relief first. So one of the things to say about relief is that relief is relative. It's to do with the refractive index, but the way we see relief, the way it's actually displayed to us and the way our eyes perceive it is always relative. So in this thin section here, for example, this is from one of the virtual microscopes, and you can see that there's a definite contrast in relief, and it's that contrast that you're looking for every time. And with a sort of large-scale view like this, where you're looking at much of the thin section, it's quite easy to pick out individual minerals with very, very strongly contrasting relief. And I've highlighted some of those there. Even though you can't, you know, some of the matrix grains might be mixed up and there may be more than one low relief mineral in that ground mass there, but you can pick out some of the individual minerals very well. And that's another thing really to say about, in general, about thin sections, is it's always a good idea to start off looking at a wide view of the section. And I'll probably reiterate that further on. It's very important when you're deciphering histories of rocks. But even just for sort of very simple things like relief and mineral identification, it can come in very handy. Because one of the things that in many rocks, and particularly metamorphic rocks, can often stand out is the relief, different relief of different types of minerals. So here, for example, you can very clearly see that there are you know, sets of minerals. So there's a high relief mineral which is forming quite large, mainly more or less equidimensional or rounded porphyroblasts, so that's large crystals. And that has a similar appearance, a sort of a mottled grey appearance across the slide. So you can pick out that that might be one mineral you can identify. And I imagine that most of you could probably identify that, particularly if I told you that it goes black under cross-polarized light. So that's one mineral. And then you can see possibly another mineral, which is a kind of dark brown mineral like this. And that again has what looks like fairly high relief, moderate to high relief, but it's very strongly colored. It's colored a brownish color. And that tends to form crystals which are slightly smaller than the other mineral. And you might also pick out that there is this changes in color as well. So there are some paler brown crystals here as well. And in fact, there's a whole spectrum of these size of crystal running from very darkest brown to very palest brown. And again, that's a relatively easy mineral to identify. You probably know that that is biotite, a very common mineral. But even if you didn't know what those two minerals were, you could see that there were two different types of porphyroblasts, two different types of mineral in that section. And having that kind of perspective early on is very, very useful for mineral identification, because it means you're not looking at every tiny grain and trying to identify it just on the properties from that one grain and then moving on to the next. You can kind of set out in your head an idea that, okay, you've got one very high relief mineral, you've got one brownish mineral, which is rather smaller and is rather lower relief, and then you've got potentially a whole load of other low relief minerals in the ground mass. And that can be a very useful way to sort of pick out the differences in a thin section. So as I say, relief is relative, so you're always looking at one mineral against another mineral, or sometimes you're looking at one mineral against the edge of the slide, against the resin that the thin section is actually made of. So just to kind of expand on that theme slightly, if you have a rock like this one here, this is a peridotite, a mantle rock, and if you have a rock like this one where virtually all the minerals have high relief, then it's very difficult because you can't see any of them particularly standing out. In fact, the only mineral really that stands out here are these coloured minerals here, and that's the spinel. But the only reason that stands out is not particularly relief, because its relief is only a little higher probably than the other minerals, but it's mainly to do with the colour. Your eyes pick out the colour. But the other minerals, the olivines and the pyroxenes in this rock, have quite similar relief, and so they don't really stand out against each other, because the relative relief difference is very, very small. So if you looked at that rock and you didn't know what it was, then most of that colourless part of the rock, you could almost believe that that might be quartz and feldspars, because you don't have any kind of context for how high a relief that is, and you'd have to look at other diagnostic properties to be sure. So that's another key thing about looking at relief. So I thought what we might do is we might try and do a poll. what I thought we'd do is have a look at this thin section. This is zoomed in quite a long way, okay? So you can see on the left-hand side, you can see the millimeter scale. That makes it a little bit blurred. Let's see if we can guess which of those lettered minerals, labeled minerals, is the highest relief, if you could all vote on that. So the highest relief, that means it's got the highest refractive index. We've got mostly C's and we've got a single D. C is absolutely right. That's the high relief. You don't see much of that grain, but this is this grain up here. C is garnet. So fairly familiar, particularly once you get to the metamorphic section of the course. And you can see that it's got a very distinct outline, so a very definite crystal edge, quite bold, and it also has a kind of mottled grey interior. And for many high relief minerals, that's absolutely diagnostic and very typical. And the reason for that is that any imperfections in that crystal show up rather like a crystal edge or a crystal boundary. So they have that same kind of high relief texture. And what that does overall is it gives this funny sort of greyish mottling. Even though garnet is meant to be either colourless in thin section or a sort of very pale pink. Usually you don't see that. You just usually see this greyish colour. Okay, let's go on to another one. Try another one. How about the lowest relief mineral? A, B, C, or D? Okay, so we've got some for B, we've got some for D. Mostly B's. Excellent. That's right. So D takes up much of the slide here, this mineral D. But if you look down into this corner where I've labelled the B, you can see that the edge of that patch of very, very clear mineral actually does have a definite relief compared to the D, the rest of the D mineral. So on this right-hand edge, you can definitely see that the clear B mineral looks as if it's kind of set in, it's lower down in the slide, and the D mineral looks as if it's kind of embossed. And that's what we mean about the relief. It looks like it's sort of standing slightly proud of the B mineral. So that's absolutely right. The B is the lowest. Let's move on again, slightly trickier one. This is a read the question really. So second lowest. What's the second lowest relief mineral? We're getting quite a few coming in as D. We've got a random A. And that's quite an interesting answer. I'll come back to that. Yeah, mostly D's. Excellent. So it is in fact D. That's the second lowest, and you can see that it's not far off being as low relief as B. The problem with A, this mineral up here, the brown mineral, and that's biotite. So it does look quite a similar relief to the D mineral, the one next to it. In fact, this sort of long lath-like shape here is actually a nice well-formed crystal of D, of muscovite. A is biotite, but often the colour of the mineral makes it look as if it stands out more. But it is in fact higher relief biotite than muscovite. So although I think one or two of you might have thought, oh, hang on, the colour is kind of tricking me, and maybe it isn't actually as high relief as all that. In fact, biotite is slightly higher relief than the muscovite. I think what you're seeing here, in fact, it is a sort of 3D effect. It looks a little blurred, doesn't it? Now, my guess is that that is either an effect of the thin section itself, the sort of three-dimensionality of this thin section. And what you might be seeing there is the edge of the biotite is at an oblique angle to the thin section. So it kind of it dips down at a low angle, a sort of 20 or 30 degree angle. And when you get an edge like that, it's much less sharp and well defined. If you've got an edge of a crystal which is cutting, at 90 degrees straight down into the thin section, then it's very clear. So I suspect that this muscovite here, for example, the edges of that are probably cutting almost straight down into the thin section, so they're very, very clearly defined. So that's one reason for a blurred edge. Another reason for a blurred edge is actually possibly slightly like this garnet up here, I think. It may be that the mineral is slightly breaking down. You can sometimes have that sort of clear edge actually blurred just because it's altering to a very fine-grained aggregate of other minerals. Okay, let's move on. So this is really what I've just been saying, actually, is that the strong colour of a mineral can confuse you and can obscure the relief. So here we've got another set of minerals. This is from another virtual microscope section from a gneiss in the virtual microscope that we've got, the OU one. So you've got the high relief titanite here. That's you may know it as sphene. But the biotite is a bit of a problem because some of the biotites, like this one here, for example, they look quite high relief in many ways because they're very, very strongly coloured. So the trick with a pleochroic mineral like that is to look for a poorly coloured, weakly coloured, or paler section of the mineral, and that's the best place really to judge its relief compared to other minerals. And the reason for that really is that obviously if you want to judge the relief of minerals, colourless minerals against each other, then you ideally want to judge other colourless sections of a mineral. So judging the biotite, the palest biotite against the colourless ground mass there is the best way forward. So I hope everyone can see and is happy with this sort of order here that I've got. You've got the titanite, which is the highest relief. You can just see it looks a little more mottled and darker, and it kind of stands out even from the less high relief one behind it, which is the next one. That is epidote, which looks slightly clearer, slightly less grey. And then we go down through the biotites in various orientations, and eventually to the ground mass, which is plagioclase. And the plagioclase, this is quite a large plagioclase crystal here. In fact, this whole area here is actually plagioclase, one plagioclase crystal. But in fact, what you're seeing in there as well are tiny little bits of epidote as well, high relief epidote in there, which is part of the plagioclase alteration. So a couple of other things to just pick up on high relief. Crystal edges tend to look very bold, but also the cracks, any cracks within the crystal very often look very, very bold and black, and that's particularly true of a mineral like this, which is olivine. And you can see that these sort of irregular curving cracks that run through the crystal are really, really bold. And that is partly, at least, to do with the high relief. In olivine's case, sometimes you get alteration along those cracks as well, and that can help to actually show up and make them even more black. Actually, that's a reasonably fresh olivine. Olivine alters very, very quickly indeed. So these sort of patches at the edge, these brownish patches here, and this sort of patch down here, that's all alteration of the olivine. It's breaking down to serpentine minerals at the edge, and that's very, very common. So these sort of patches in here, in between the cracks, are relatively fresh olivine. It doesn't take much to, yeah, it's only happy in the mantle. That's absolutely right. So here you've got, you know, the highest relief olivine. You've got these other moderately high relief pyroxenes, which again look fairly grey, but you can see the crystal edges are much less bold, and then you've got a low relief ground mass.